Hi there, welcome to Waferank. Waferank is into a mission of bridging the gap between colleges and industry. We help students of various streams to make the first step into VLSI. So let's get started and see what the future holds for you. Today's agenda is as below. We will start with VLSI for beginners, the VLSI product life cycle where we will understand what cycles chips go through. We will also understand what VLSI companies are there in India and what they do. We will understand how you can choose a domain for yourself through domain-wise criteria and prerequisites. Then we will understand little more about what Waferank does for participants, talk about Waferank programs, domain-wise curriculum. We will show you our placement status. Finally, we will have a small session for question and answers.
Many inventors worked on bringing the first semiconductor chip. Most notable names are Robert Noyce and Jack Kilby. That's where we kick-started into small-scale integration in the year 1959. For several years, the first chip had up to 10 devices. Then medium-scale integration on a little bigger scale started with up to 100 devices. Large-scale integration came into existence with more than 100 devices up to 10,000 count. Major chips today are still VLSI, very large scale integration. They generally have devices count between 10,000 to 1 million devices. Most of the high-end chips like mobile processor, desktop processor, server processor, graphical cards, RAM, ROM, etc. are of ULSI. They house devices from millions to billions into a single chip. However, since majority of the chips, almost 90%, are still VLSI, that's why this particular area of work is called VLSI. Semiconductor chips are used for a variety of applications. Most chips go into communication and computers. They consume almost two-thirds of the total uses. All of us today have phones and laptops, and that's how we are the biggest consumers. Remaining uses are into automotive, consumer appliances like fridge, TV, washing machine, gaming consoles, musical devices, wearable, etc. Few percentage of the chips are also used by government for space applications. So all in all, semiconductor devices touch everyone through consumables.
54% of the chips are manufactured by TSMC. Samsung has a contribution of 15%, UMC 7%, Global Foundries 6%, SMIC 6%, and all the other chip manufacturers together are 12%. If you see, all the other 25-30 foundries together also cannot beat TSMC on chip production. They are one of the most advanced too. They are able to manufacture chips of 2 or 3 nanometer also, which is not possible for other foundries.
If you see the technology spread, chips are manufactured from 500 nanometer feature size to 2 nanometer, and they are spread across multiple sectors like image sensors, memories, radio frequencies, logic, analog, high voltage, to name a few.
These are VLSI domains inside and out. We have hardware board design and testing, hardware chip design, embedded software. Chip design is the most sought after jobs thanks to highly satisfying and highly paid job in nature. Under hardware chip design, these are the domains. Most notables are DV, design verification, PD, physical design, circuit design, layout design, design for test, DFT, RTL, real-time logic, FPGA, field programmable gate array. A chip goes through many design cycles. A typical design cycle is represented by the flowchart shown here. The interesting fact is that all the domain like circuit design, layout design, design verification, physical verification, RTL, DFT, FPGA are jobs which are required to make this flowchart. If we try to understand the flowchart, then we start with system specification. We do the architectural design verification. Actually, that's where the DV is. Design entry, we have functional simulation, formal emulation, FPGA prototypes, which we do. Then we get into synthesis, STA, design for test, pre-layout, post-layout, physical layout, IC fabrication, and then we go into production. Now, let us understand what companies are into VLSI and what they do. Intel and AMD are into desktop, laptop, server processors, graphical processors, and range of state-of-art 5G, 4G, Bluetooth, Wi-Fi chips. They are also into other segments. We have NVIDIA, which is into graphical processors, but also into other areas. We see Qualcomm, MediaTek, Google, Apple, Samsung, and Huawei. They are into mobile processors and range of high-speed modern chips like 5G, Bluetooth, Wi-Fi, and routers. Further, Broadcom is into memories for data center and 5G and other high-speed chips. Micron is a memory giant. When you buy RAM, SSD, etc., there is a 90% chance that it comes from Micron. Facebook Meta has started with data center chips. Western Digital is also into storage and other areas. SK Hynix is a memory giant. Then we have companies like Microchip, NXP, STMicro, Texas Instruments, MaxLinear, Analog Devices, onsemi, Infineon, who are analog companies and focusing on solar, automobile, and industrial grade products. Marvell and Rambus are into high-speed links. Cisco is into networking chips. Xilinx is into FPGA. Novell is into audio, and Sony is into TV processors and image sensors. Then there are IP companies who are into product licensing, meaning they design and develop and sell it to other companies. Then there are VLSI major foundries. Ultimately, all the chips that are designed needs to be manufactured. These are the list of few companies who are into fabrication. Pure semiconductor fabrication companies are TSMC, Global Foundries, SMIC, XFAB, UMC, and many others. Some companies like Intel, STMicro, Micron, Samsung, and most of the analog companies have their own foundries too. There are service companies too. When you're hunting for a job in VLSI, product companies are not the only ones. You can target more than 100 service companies too. The big ones are TCS, Infosys, HCL, Wipro, Tech Mahindra, Altron, Synapse Design, Alton Calsoft, UST Global, etc. Then there are emerging companies like Moschip, Mirafra, Bitsilica, Signoff, Insemi, Excelmax, Lead IC, and LeadSoc.
If you want to choose a particular domain based on your strength, then this slide is for you. You can choose circuit design if you are from premium colleges like IIT, NIT, IIIT, BITS, VIT, etc. For circuit design, difficulty is high and pay scale is also high compared to other domains. You may try for this domain even from normal college though. Second one is design verification, and RTL requires some kind of programming skill, and anyone from normal college can opt for it. DFT is a tough domain. Engineers from premium colleges are preferred. Layout and physical design is somewhat easy and are part of back-end design. All in all, major domains to choose from are layout design, design verification, and physical design. These are the prerequisites for each of the domains. First one, circuit design requires more skill in simulation, debug, and circuit analysis. Second one, some of the program require programming. Third one, some require digital understanding. Fourth one, layout requires analog understanding along with circuit. It's almost impossible to get an entry into VLSI for most of us, even after PhD. So let's ask two questions. Why VLSI job needs training and why VLSI training is costly? Firstly, let us understand where the tool comes from. Worldwide, only three major companies are suppliers of VLSI CAD tools. Cadence, which is used by almost 80% companies and users. Synopsys is used by 10% of the companies. Mentor Graphics, which are acquired by Siemens and others, contribute less than 10%. Keeping them on the side now, we also must know that VLSI jobs are skill based. You need to develop certain skills specific to the job. VLSI jobs are also tool based. That means you need to build expertise into specific tools. It costs millions of dollars for production grade license of the tool. Training licenses are highly regulated and given to selected universities and colleges and training institutes. So why VLSI training is not cheap? It is due to the tool prices.
When is the right time to start VLSI training? You can start your VLSI training as early as before finishing your degree. These are called early years program where you will have a lot of time to prepare your foundations. Then you can start even once you're finishing your degree. This is going to be a stressful situation if you're not having a job in parallel. That's why we suggest that you start the course before your degree completion, or just after your college, or the last chance is you can get into another job, parallel job, and you can still do a VLSI training and come back to a VLSI job. Is it worth making VLSI career or switching from other jobs?
But the reward is VLSI is highest paying job. For electronics, its core domain. No other domain comes closer to core domain in electronics. Salaries are very high. On average, 5 years experience engineers get 28 lakhs compared to 15 lakhs on software jobs.
There are three different kinds of job which you can get after your degree. One is a non-technical job, meaning this kind of job does not need you to go through any degree at all, like call center jobs and others, where salary, growth, and satisfaction, all three are going to be limited. Then there is a technical and non-VLSI job. So in this sector of job, you will get salary, you will get good growth, and you will get good satisfaction as well. And then comes the VLSI job, where the salary is going to be much higher, growth is going to be very good, and the satisfaction also is very, very good. Let us understand what is the degree and technical requirements for starting a VLSI job.
Let us understand the eligibility criteria. Anyone who has electronics basic can opt for it, starting from BSc, MSc, Diploma, Bachelor of Engineering, Master of Engineering, Bachelor of Technology, BTech, MTech, and PhD. All are eligible. You can take up a course either in final year or pre-final year. You can also take up a course after your college, but you will be unemployed after your college, so better to take up in the final year. Stream-wise, electronics, telecommunication, communications, electricals, computers, instrumentation, all are eligible to make a great career in VLSI. What should we know if you want to get into VLSI? Okay, so there are these topics which are supposed to be known. Okay, basics of electronics, device physics, semiconductor theory, digital basics, RC network, little bit of programming. You must remember that it would hardly take 1 week to build expertise on these topics, so it's easy to get through. Now, coming back, what is Waferank? Waferank is run by tens of volunteers with a common goal of helping students come into VLSI smoothly. How Waferank can help you? We run various programs time to time based on industry demands. We can help you with sponsored trainings which are sponsored by participating colleges or companies looking for you. We can get you internships, entry-level jobs, and regular training also in any of the domain of VLSI you choose. You can choose from trainings which happen with Waferank, we conduct with the help of our partners, internships which is offered by our participating companies, and entry-level jobs. We post it in our LinkedIn handle or send it to students on WhatsApp from time to time.
These are the major domains in VLSI where we have training: circuit design, layout design, physical design. These three are part of backend design. Then there is a design verification, ASIC design, and FPGA design. There are three types of training programs Waferank runs. One is classroom training. This is offline in nature. Then there is an online training. You can attend the training from the comfort of your home. And then there is a weekend training for anyone who is actually doing their college and trying to do the VLSI course, or they're working somewhere, right, software or any other domain, and they want to switch to VLSI. So weekend training is for them. These are the course features: basics preparation. Second one is recorded class. For easy reference, you can go through the class recordings anytime. 24 cross 7 tool access. Experienced trainer. So all the trainers are 10 plus years of experience. Project is designed by industry experts. 100% placement until you are placed. Duration is 4 to 6 months. Mode of training is online or offline. Certification is training come intensive certificate will be provided to you, and you must know basics of electronic, RC network, digital electronics, CMOS, device physics, etc. Eligibility is you can start from your third or pre-final year onwards. You can join any course. The domain where you're eligible for is electronics, electrical, computer, or similar, which covers basics of electronics. This is the general flow of training, right? Once you're enrolled, there will be common basic class for 2 weeks, and then you can decide your domain. You can get into DV, design verification, physical design, circuit design, layout design, DFT, RTL, and FPGA. This is the general curriculum for ASIC verification, right? So in the module 1, we start with digital system design. Module 2, we start with Unix. Module 3 is about revising your C and OOP concept. Module 4 is about hardware design language. Module 5 is about hardware verification language. Module 6 is about UVM methodologies. Then module 7 is about, protocols like AMBA and others. The layout design curriculum is as below. So module 1, you go through a lot of basics. Then you go through tools. Module 2 is about analog layout concept. Module 3 is about advanced analog layout concepts. Then there is a practical. You will have to do 3 or 4 projects. And then there is a digital module also. Like, you can get into memory, standard cell, and all other kinds of layout possible. In the physical design curriculum, we start with Unix, we go into IC design flow, then CMOS fundamentals, data types and flow basics. We get into floor planning, power planning, placement, all these, and then we get into clock tree synthesis. And in the module 8, we go into routing, module 9, STA fundamentals, and finally module 10, you will end up with sign off. This is the curriculum for circuit design. So this is divided into 3 parts: theory, practical, and tools. So on the theory side, we will start with fundamentals like resistor, capacitor, inductors, diode, bipolar, MOSFET, all these characteristics. We will go through amplifiers, op amps. Then we will get into LDO also, band gap, two-stage amplifier, and all that. On the tool side, we will go through Unix demo. Then we will show you, the tool and simulations and all those things. And in the practical side, you'll be doing multiple projects. You can choose between LDO, BGR, PLL, GPIO, and then there are a lot of other projects we can choose and you can do. Thanks for your time. You can call us or communicate using WhatsApp on below numbers. You can also mail us. You can like and subscribe us in YouTube. You can also follow us on LinkedIn for entry-level job updates. Goodbye from Waferank, your first step into VLSI.